Okay, this is a quick video on what we call internal resistance and EMF. So traditionally in like Key Stage 3, we've talked about what we call voltage. And that's the power supplied by or used by a device. In reality, we should be talking about EMF, which stands for electromotive force. This is the power supplied to the circuit by your power supply, your battery or your power pack. PD as your potential difference. This is whatever's used by the circuit components. And these two, according to Kirchhoff's first law, these two should be equal. The sum of the EMF should equal the sum of the PDs. And that's a useful concept. That basically covers EMF. In physics, we're not too worried about how the EMF is generated so much as what it's used for. Then, it stands to reason, if you've got a circuit with a power supply and let's say a light bulb in it, we traditionally thought, well, 6 volts supplied, 6 volts used. But in reality, although the supply might be 6 volts, the wires might be using like 0.1 volts, which is going to reduce the potential available for the light bulb. Also, within the cell, there's going to be some distance for it to cover, the current to cover. And therefore, if the chemical reaction inside a cell or a battery is providing 6 volts, some of that 6 volts is used just to get out of the cell. So let's say maybe 1 volt is used to get out of the cell, leaving us with 5 volts for the circuit. That 1 volt is known as lost volts, and that is a result of what we call the internal resistance of the power supply. And that's internal resistance. Because it's internal resistance, everything associated to it, we tend to use lowercase. So we might talk about the resistance of the bulb, and then we talk about the internal resistance of the power supply. And in some circuit diagrams, when we're talking about it, we'll even draw the little internal resistor within the power supply that's part of the circuit. So your core practical 3 is you're going to try and find the internal resistance and the true EMF of a power supply. We're going to use a power pack. We're going to set it to, let's say, 2 volts. And we're going to look at if it's providing out 2 volts, what's it actually generating in order to achieve that, because there's wires within the power pack creating internal resistance. So to do it, we use, we're going to set up a circuit, a power supply set to 2 volts. It's got its little internal resistor. We're going to attach it to a variable resistor with an ammeter in the circuit and a voltmeter across it. According to Kirchhoff's first law, the EMF equals the lost volts due to this plus the volts used by the variable resistor. And then we can put Ohm's law into it. We can say E equals the current times the resistance, because V equals IR. That's our formula, but if we rearrange that a little bit, if we make that V equals negative IR plus E, or even in fact, if we switch the I and the R around, negative RI, we have something that vaguely resembles Y equals MX plus C. So we can plot a graph of V against I, and our y-intercept will be the EMF, and our gradient will be negative R, so the inverse of it. So that's what we're going to do as an experiment. Okay, here is the equipment that we used for this experiment then. So we've got the power supply, leads coming out, going to a voltmeter, coming around and going to a variable resistor, coming back out and back into the power supply. I've set the power supply to 2 volts using the DC, and then I have a voltmeter over the variable resistor, as we would see in this circuit diagram. And then I've made a results table. I've already pre-done the results just to make life easier, but the way this works, then we turn on the power supply, we get a current and a voltage reading, and then and you can see that the readings on there at the moment are the last ones on my results sheet. And then if we slide the variable resistor, we should see that the current increases as the resistance decreases, and the voltmeter reading goes down where it's using less potential. And so I created these results to go with the experiment using that circuit setup, and then I was able to plot a graph of the points, draw a line of best fit, see if we can get it to focus. And then that allowed me to find a y-intercept of 3.07, which is the EMF supplied by the power pack, despite it being set on 2 volts. And then the gradient, you can see my calculations for rise over run. I get a gradient of negative 2.16. Therefore, the resistance, the internal resistance, is 2.16 ohms. Last thing to do is to think carefully about a risk assessment for this experiment.